Do you actually read the comments and questions from Facebook Live too? You do?
Yeah, I'll watch them.
Okay, all right.
Yeah. And it is 7 o'clock, so we can go ahead and get started. So, welcome to an official event of the 9th Annual MSU Science Festival. My name is Hazel Anderson, and I'm a member of the Science Festival team. Tonight with me, I have Nicolle Zellner, who's going to talk about the Albion College telescope. So, take it away.
Well, thank you so much for having me. I'm really excited to talk about the historic telescopes that we have at Albion College. I'm going to go ahead and share my screen and get this presentation started. All right, so you should be seeing my presentation on the screen now. And I'm going to minimize my face here. All right. I'm giving it away. All right, so the first thing I want to just say is I am not a historian. I am a practicing planetary scientist. I'm a professor of physics at Albion College. But the reason I got interested in the Alvan Clark telescope at Albion College is because it's so historically significant in terms of the college specifically, but also astronomy in the United States in general. So that is the topic of my talk tonight, but I'm happy to answer any relevant questions about women in science or being a physics professor at a liberal arts college, or even a little bit about my research if anyone out there is interested. So the Alvan Clark telescope at Albion College was built in 1883 to 1884. So the telescope itself is over 130 years old. It has a 10-foot length tube. It's known as a refracting telescope, which means it uses a lens that focuses starlight coming from space down through the tube and then focusing it at the eyepiece at the bottom. I'm hoping you can see the mouse. So I'm pointing near the bottom of the picture on the right-hand side. That's where the light from the object that you're looking at is focused at the eyepiece. It has a 8¼ inch diameter lens. So it's a glass lens that is ground in a concave and convex manner in order to focus that light down at the eyepiece. When the telescope was cleaned about 5 years ago, the telescope cleaner, the man we brought out to help restore the antique telescope, said it was almost perfectly ground. So it's a very unique lens in terms of telescope lenses. And at the bottom here, I write a sole survivor with a question mark, because there's some speculation that this telescope is one of the last of its kind in its original house. And so therefore, at Albion College, we're very proud to have such a historically significant telescope. So how did we get it and why do we have it? I'm going to talk a little bit about that. The story starts in 1882 when a professor in the math and astronomy program at Albion College named Samuel Dickey proposed to the Board of Trustees that he believed the erection of a telescope in an astronomical observatory would be of great value to the college in general. And in particular, he identified two pieces of reasoning. One is that it would materially increase the facilities for instruction, and two, it would add dignity and reputation to the college. And he says this specifically because in the late 1800s, sciences were just starting to be introduced into the college curriculum across the nation. And as one of the first colleges in the Midwest, Albion felt, or at least Samuel Dickey felt, that Albion could elevate its status nationwide if it brought in a telescope and observatory to provide for the students. He then went on to tell the Board of Trustees that he himself would raise the $10,000 from not more than 100 persons or firms, and that the only expense to the college would be travel, incidentals, and paperwork and that sort of thing. And just for note, $10,000 in 1882 is about $260,000 today. So believe it or not, he did it. He was able to raise $10,000 in less than 1 year, and the construction of the building and the telescope commenced. In 1883, the cornerstone was laid, and just a year later, the telescope construction was completed. The Albion College Pleiad, which is the college newspaper, then went on to report that the enterprise has everywhere been well supported, as shown by the hearty response of the contributors. Albion College is surely grateful to all that have contributed towards the fund, as it is through their liberality that she can soon boast of a finely equipped observatory. Right? This was very exciting for the college. The college the Pleiad and other historical records at the college went on to document the specifics of the telescope itself. It was an equatorial mounted telescope, which means that it is aligned towards the North Star, or where the Earth's axis is actually pointed right now. And it was built on a podium that you can see here in the picture. That's the painted gray blocks, a podium that went down 30 feet into bedrock. And this was important because of the major train traffic that went between Ann Arbor and Detroit, passing right through Albion then as now. And the vibrations from the trains passing through would, of course, travel up through the telescope and cause the telescope to waver and cause images to be blurred. But if the telescope was built on one of these piers, 30 feet into bedrock and also isolated from the building, then the vibrations would be, if not eliminated, at least very much reduced. One of the college myths is that the Alvan Clark himself, who was the premier telescope maker in the United States at the time, was that he himself ground the lens of our telescope, considering that it was made in 1883 and Alvan Clark was working up until 1886. It's highly likely that he had a hand literally on the lens and hand ground it, but the claim is largely unverified. But it could have been. We not only were able to purchase the Alvan Clark telescope and build the building for $10,000, but we were able to buy 3 pieces of very important ancillary equipment. And these 3 pieces were made by the Fountain Company in Washington, D.C. They are all also used for telescope observations, including in the left-hand panel, the left-hand picture, which is a transit telescope. And what the transit telescope would do would measure the positions of the stars as they passed overhead in a slit in the building that was cut into the roof. In the case of binary stars in particular, the distance between those binary stars could actually be measured in arc seconds on the sky and then translated to actual distance of astronomical units or kilometers or parsecs or light years or whatever unit of distance you wanted, using the measurements made with the transit telescope. An astronomical clock was also purchased, as was a coronagraph. And so all of these pieces of equipment continue to exist in the original building on the Albion College campus. The transit telescope and the clock are still on the original piers. The chronograph, unfortunately, was moved off the pier as the second floor was renovated over the years. So the excitement over having these telescopes and ancillary equipment at the college was was profound. And in particular, it helped increase the population of students attending Albion College. When we first started investigating the history of the Albion College telescopes, my collaborator dug into the student records, and we created this graph here that shows literally, if you build it, they will come. And population and attendance at Albion College increased exponentially, or almost exponentially anyway, after the construction of the Alvan Clark telescope. So I'm using the same argument here today with our current president and asking for funding of our more modern telescopes. And we can talk about this a little bit later, but I also want to, for those of you Michigan fans out there, remind you that at one point, Albion College was a football powerhouse, and we beat those Wolverines 10-4 in 1891, and we're proud of that. Indeed, students were excited to use the telescope. The Albion College catalog, in fact, advertised the astronomy classes and the telescope observing that the students could undertake while they were enrolled at Albion College. And though they understood that not every student would become an amateur astronomer, they at least will be improved in their education by contemplating the vastness of astronomical magnitudes, including the habits of painstaking accuracy by the nicety and precision of observation and computation. So I really love the language that was used in our catalog in 1882 and 1883. Every student who was going to graduate with some kind of experience in astronomy was required to undertake an observing experience and also do some mathematical calculations. And so now I'm going to talk to you a little bit about a few of those students who actually went on to some pretty important and prominent careers in astronomy and making pretty important contributions. The first was Wesley Underwood. He graduated in 1886, so he's likely the first astronomy student who actually used the Alvan Clark telescope, if not the transit telescope as well. He soon left Michigan and went to Wisconsin, and in particular Appleton, Wisconsin, where he became a professor at Lawrence College at the time. Now it's known as Lawrence University in Appleton, Wisconsin, very close to where I grew up. So there's a really nice connection between Wesley Underwood and myself here. And he, I think, in the believing and following in the footsteps of Sam Dickey, went to his own board at Lawrence College and said, I will undertake the completion of this enterprise and I will raise the money that's required to build our own telescope here at the college. And sure enough, within a year, the $17,000, well, actually within 2 months, the $17,000 was secured. $17,000 today is roughly, or $17,000 back then is roughly $490,000 today. So he was able to raise that money fairly quickly. They were able to purchase 2 Alvan Clark telescopes, and then he eventually became the president of Lawrence College in 1894. Unfortunately, the telescope and the observatory no longer exist in Appleton. The observatory was raised in 1862 and the telescopes were sold. The next prominent graduate of Albion College who went on to a distinguished career in astronomy is Forrest Ray Moulton. He was an Albion boy, born and raised, who then graduated from Albion in 1894. He also likely used the Alvan Clark telescope and the transit telescope as well. He went to graduate school at the University of Chicago with Thomas Chamberlain, and together they came up with the theory that planets were formed when stars collide with each other and then they rip off material to accrete into the planets that we see today. And though we no longer believe this theory, there's no observational evidence that this is actually how planets form. At the time, it garnered a lot of interest. And as a result, both Moulton and Chamberlain were honored with craters on the moon named after them. So that's pretty exciting that Albion College has an alum who has a crater on the moon named after him. Forrest Ray Moulton, again, because of this major contribution he made to the early theories of planet formation, is the only member of Albion College student body who is a member of the National Academy of Science. And that's the highest honor a scientist can achieve in the United States, or at least one of the highest honors. So Molten Crater then is, I'm going to talk to you a little bit about the science. Molten Crater is located on the far side of the moon. So when we see a beautiful full moon at night, we're looking at the near side of the moon, and the very edge of that moon, the very edge of the near side, just on the other side of that is what we call the far side. And that's where Molten Crater exists. It's right here is a beautiful lunar reconnaissance orbiter image of Molten with Chamberlain butted up right next to it. It's about 49 kilometers in diameter and roughly has an age of about 3.8 billion years old, just based on the number of craters that we count on the inside of it. The other really interesting thing about Forrest Ray Moulton is that early on, he became an expert in solving problems of celestial dynamics. And in particular, he was the one who figured out how you can turn a circle, right, that goes around and around a planet, for example, into a parabola. So a parabola, remember, is one of these arches in graph, that you might see graphed. And one of the really hard jobs when we were trying to launch people into space and return them safely to Earth was to figure out where in that orbit we could change the pattern of flight and turn it into a parabola. And so those of you who have maybe seen Hidden Figures might remember that Katherine Johnson, the math genius at the time, was the one who figured out how you can turn that circular orbit into a parabola and return John Glenn safely to Earth. She had a light bulb moment when she realized that it was really due to celestial mechanics. And this is a page from the textbook, I'm sorry, not the textbook, but from the book, Hidden Figures, which I read. And I got to this page where the author mentioned this book called Introduction to Celestial Mechanics, a 1914 text by Forrest Ray Moulton. And I said to myself, I know that guy. That guy came from Albion College. So it turns out that Katherine Johnson actually used the proofs that Forrest Ray Moulton had published in order to figure out how to bring John Glenn back safely to Earth. So that's a very exciting connection that we have with space exploration as well. The next prominent alum from Albion College is a guy named Wilbur Cogs Hall. He graduated, again, kind of in this golden age, right when the observatory was built in 1895. And he worked for a few years at the Lowell Observatory in Flagstaff, Arizona, observing binary stars. Shortly after that, he arrived at the University of Indiana, where he lived the rest of his career and had a very prominent career in the astronomy department at Indiana. What's interesting about Cogs Hall is that he convinced Percival Lowell, who went on to observe the canals, the quote unquote canals on Mars, to hire a guy named Vesto Slipher. And Vesto Slipher was really interested in the redshifted spectrum of galaxies. And so he measured how quickly he measured the compositions of galaxies and actually realized that those spectra were redshifted or in longer wavelengths from where we expected them to be. Edwin Hubble, 30 years later, went on to use that information from Vesto Slipher to show that the universe was expanding. Cogs Hall was also at the Lowell Observatory at the same time that Pluto was discovered and actually received advance notice of Pluto's discovery and was asked to verify some of the orbital parameters before the announcement was made. So that's pretty exciting connection of Cogs Hall with the Pluto discovery. After the 1890s, particularly after World War I, the observatory fell into disrepair. It served as a barracks for soldiers who were coming back from World War I, as well as on their way to World War I. Shortly after the observatory fell into repair, the astronomy courses were removed from the curriculum. For the next 20 years or so, the telescopes sat idle, and according to Cook, who did a historical survey in 2004, there was an accumulation of dust and rodent droppings, not to mention the rodents themselves. So it wasn't a really great place to hang out. But have no fear, because Marvin Vann arrived on the scene. He was a freshman in 1936, and he approached President Seton and he offered to clean and repair the building. The president replied, "Given the condition of the observatory, the two students couldn't make it any worse." So Marvin Vann and his friends went in, they cleaned up the observatory, they restored the telescope, and within a year or so, the astronomy courses were reinstated, and they have continued ever since. In 1965, the first major cleaning and renovation by professionals happened. A team from the Yerkes Observatory in Lake Geneva, Wisconsin, came to Albion College to clean the telescope. Harlow Shapley was one of the people who attended. Harlow Shapley is most famous for observing globular clusters around our galaxy and identifying and figuring out where it is in our galaxy that we, Earth, and our solar system is located. He took one look at our telescope and he said, "Ah, I see you have a Rembrandt." He knew how special the Alvan Clark telescope was as well. In 1985, the observatory was designated as a Michigan historical site, as it remains today. And once again, a student took charge and undertook another renovation. Jim Ehlers, who graduated in 1994, did another cleaning of the telescope and brought the telescope paint itself back to its original colors in the observatory. The Alvan Clark telescope at Albion College is not the only old telescope in Michigan, and I really do need to honor the other old telescopes we have or had here in Michigan. The Detroit Observatory in Ann Arbor was built in 1854. It's probably the oldest observatory that we had. And it had a 3-inch Alvan Clark telescope, but it is currently not in use. Norb Vance at Eastern Michigan University is sitting here in this picture with a 4-inch Alvan Clark telescope. And again, the 4 inches has to measures the lens itself, which was built built in 1872. And the Michigan State Observatory as well had a 5.5-inch Alvan Clark telescope that was designed and built in 1879. When I was, the last time I was at the observatory, the last time I was at the Abrams Planetarium, it was on display. So I hope it still is, though it's been a while since I've been there. So, I think that it's true, at least in the state of Michigan, the Alvan Clark telescope is the sole survivor of a telescope of its size in its current house. Whether or not that's true around the nation is still to be debated. So today, the telescope and observatory are still in use by appointment only, and students don't use the telescope at all for research. Instead, they're using the telescope that we have on the roof of Polensky Hall. But we do have public observing nights with the telescopes, particularly during homecoming and other special days when we have lots of visitors on campus. On the right-hand side, we can see a modern-day picture of the observatory taken from the quad, and the arrow is actually pointing to that slit that used to open and close for the transit telescope to observe the stars passing overhead. It was permanently covered over in the early 1980s. And with that, I will stop my presentation, and I'm happy to answer any questions. Thank you.
Yeah, thank you. That was great. So if anyone has any questions, if you're watching on Zoom, put them in the Q&A. If you're on Facebook, you can comment. I can start. So what got you interested into astronomy, just in general?
Yeah, that's a really great question. I grew up out in the country in Wisconsin, outside of a very small town where it was really dark all the time. And we'd go outside and just observe the beautiful sky, no light pollution out there, the Milky Way, the Northern Lights, and stars themselves. But it was probably in 5th grade, our family went on vacation to Hawaii, of all places, and I saw a planetarium show at the Bishop Museum about how the Polynesians used the stars to navigate and migrate from the South Pacific up to the Hawaiian Islands. And I thought that was just really, really fascinating. And I was kind of stuck on the stars ever since.
Yeah, looks like we have a question in the Q&A. How much does the optical tube weigh?
Oh, that's a really good question. I think it's something like close to 1,000 pounds. Something like that, if I remember correctly. It's because it's very long, it's easy to move. But if I had to and it's got a pivot point as well, that makes that leverage really, makes it easy to maneuver around. But it's something close to 1,000 pounds total. I hope I never have to disengage it and weigh it though.
Yeah. Matthew asked, are there any images available online? I'm not sure if that's referring to the telescope or like views from the telescope.
So some of the pictures that I showed for the moon, for example, we're pretty sure that was taken by the telescope. We're with the telescope back whenever that postcard was published. Because it's an 8¼ lens, it's not great. And because in order to take an image, you have to be able to track, for example, as the Earth is rotating on its axis, you have to be able to track in order to get that image of a planet, for example. And that's pretty tricky. It wasn't really an imaging telescope. It was more a telescope used to collect photons and to collect a spectrum of a star or to collect a spectrum of a binary system, for example, and not really used as an imaging telescope.
Interesting.
Yeah, and other images in general can be found in the Albion College archives and on the Albion College websites.
Awesome. So you didn't really talk about your research, but what kind of astronomy research are you doing currently, past, present, future?
Thank you. So I'm a planetary scientist. I actually study samples from the moon. And my research focuses on these microscopic pieces of glass called lunar impact glasses that are formed when an asteroid or a meteorite hit the moon and then melted that regolith into little glass beads. And those glass beads can tell us when the bombardment happened, which can help us address questions related to the impact history in the Earth-Moon system, the delivery of biomolecules, and the cratering rate in general, and how that may have affected the origin of life on Earth. So maybe that'll be my talk next year.
Yeah, there's lots there.
Yeah, it's a lot.
What?
We're very excited for the administration's current presidential administration's desire to return to the moon, to land the first man or the next man and the first woman on the moon in the very near future, provided funding allows it. So that's very exciting, and to get samples back as well will be very exciting for us in the lunar science business.
Yeah. So are most of your samples then really old, since we haven't been to the moon in a while?
Well, I mean, they're old because they came from the surface of the moon. So some of them certainly are about 3.8 billion years old. But yes, they've been on Earth for about 50 years. So, but most of them obviously are quite old. Yeah, and they're from the Apollo collection. So the Apollo samples.
Yeah. It looks like we're almost out of time. If anyone has any last minute questions, but thank you so much.
Thank you.
Great.
Thanks for having me, and go science.
Yeah. For people joining us, be sure to check out the rest of the events happening tonight. I think there's only one more, but there's lots of events still happening tomorrow for Expo Day and throughout the rest of April, and you can find them on our website at sciencefestival.msu.edu. Thanks again.
Thank you. Bye.
Bye.